NENOMATICA, where mathematics meets YouTube excellence. Today, we'll work through a step-by-step solution of a polynomial expression and simplify it completely. Let's look at our example. We need to simplify the following expression: 2x cubed minus 2 times the quantity x minus 2 times the quantity x squared plus 2x plus 4 minus 2 times the quantity x minus 1 plus 2x squared plus 4. First, let's focus on this middle term. We'll apply the distributive property to multiply the expression x minus 2 by x squared plus 2x plus 4. We'll expand by multiplying each term in the first bracket by each term in the second bracket. So we have 2x cubed minus 2 times the result of multiplying x by x squared, which gives us x cubed, plus x times 2x, which gives us 2x squared, plus x times 4, which gives us 4x, plus negative 2 times x squared, which gives us negative 2x squared, plus negative 2 times 2x, which gives us negative 4x, plus negative 2 times 4, which gives us negative 8. Now, let's simplify the expressions inside the brackets. We'll multiply each term according to the exponent rules and simplify. So we get 2x cubed minus 2 times the following: x cubed plus 2x squared plus 4x minus 2x squared minus 4x minus 8. Then we continue with the rest of the expression, which is minus 2 times x minus 1 plus 2x squared plus 4. Let's combine like terms inside the parentheses to simplify further. We'll group together terms with the same variables and exponents. Inside the first parentheses, we have x cubed, and the x squared terms are 2x squared minus 2x squared, which cancel out to 0. The x terms are 4x minus 4x, which also cancel out to 0. And then we have negative 8. So we get 2x cubed minus 2 times the quantity x cubed minus 8, minus 2 times the quantity x minus 1, plus 2x squared plus 4. Now, let's apply the distributive property to negative 2 times x cubed minus 8. We distribute the negative 2 to each term inside the parentheses. This gives us 2x cubed minus 2x cubed plus 16 minus 2x plus 2 plus 2x squared plus 4. Let's combine like terms in our overall expression. We'll group together terms with the same variables and exponents. The x cubed terms are 2x cubed minus 2x cubed, which cancel out to 0. We have 2x squared, which remains as is. The x terms are negative 2x, which remains as is. And the constant terms are 16 plus 2 plus 4, which is 22. So our final answer is 2x squared minus 2x plus 22. In this video, we'll solve and simplify the algebraic expression a plus b times b plus c minus left parenthesis c plus d right parenthesis times left parenthesis d plus a right parenthesis minus left parenthesis a plus c right parenthesis times left parenthesis b minus d right parenthesis. We'll go through this step by step to arrive at a surprisingly elegant result. Let's start by working through the problem methodically. Our example shows the expression we need to expand and simplify. Our first step is to expand each of the three products in this expression. We'll use the distributive property to multiply each term in the first parenthesis by each term in the second parenthesis. Now, let's apply this property to expand each of the three products in our expression. For the first product, a plus b times b plus c, we multiply each term in the first bracket by each term in the second. A times b gives ab, a times c gives ac, b times b gives b squared, b times c gives bc. For the second product, c plus d times d plus a, we follow the same process. C times d gives cd, c times a gives c, d times d gives d squared, d times a gives dA. For the third product, a plus c times b minus d, we need to be careful with the signs when distributing. A times b gives ab, a times negative d gives negative ad, c times b gives cb, c times negative d gives negative cd. Now, let's substitute these expanded products back into our original expression and distribute the negative signs. Let's substitute our expanded expressions into the original formula. We have the first product, ab plus ac plus b squared plus bc, minus the second product, minus cd minus ca minus d squared minus d, minus the third product, minus ab plus ad minus cb plus cd. Now, the most crucial step is to combine like terms, cb plus cd. Now, the most crucial step is to combine like terms. Remember that in algebra, like terms have the same variables with the same exponents. Let's combine like terms by identifying terms with the same variables. First, let's look at terms with AB. We have AB and negative AB, which sum to 0. For terms with AC and C, which are equivalent, we have AC and negative C, which also sum to 0. For BC and CB, which are the same, we have BC and negative CB, which cancel out. For CD, we have negative CD and positive CD, which sum to 0. For AD and DA, which are equivalent, we have AD and negative DA, which also cancel out. The only terms that don't have matching pairs to cancel are B squared and negative D squared. Interestingly, our final answer can be expressed as the difference of squares, which has its own special formula. So our final result is simply B squared. Answer can be expressed as the difference of squares, which has its own special formula. So our final result is simply B squared minus D squared. Let's verify this makes sense by thinking about the structure of our original expression. After all that algebraic manipulation, we arrived at a remarkably simple result. Quick challenge. Can you think of another way to approach this problem? For example, could you factor the final result B squared minus D squared using the difference of squares formula? In conclusion, we've seen how systematic algebraic manipulation can transform a complex-looking expression into a simple one. We expanded each product, distributed negative signs, and combined like terms, resulting in the elegant answer B squared minus D squared. This example demonstrates the power of algebraic manipulation and how complex expressions can sometimes simplify to surprisingly elegant results. Thank you for watching. Resulting in the elegant answer B squared minus D squared. This example demonstrates the power of algebraic manipulation and how complex expressions can sometimes simplify to surprisingly elegant results. Thank you for watching. Manipulation. Welcome to this math video where we'll solve an algebraic expression problem. We need to calculate the value of the expression b minus a squared, all raised to the power of 2000. We're given two algebraic expressions. A equals 4 times the quantity x squared plus 3, minus 2 times the quantity x minus 2 times the quantity 2x minus 3, and b equals 14 times the quantity 2x minus 1/7 times the quantity 7x plus 1/2. Let's start by simplifying expression a. First, we'll expand the first term. 4 times x squared plus 3 equals 4x squared plus 12. Next, let's expand the second part. 2 times x minus 2 times 2x minus 3. Using the FOIL method to multiply these binomials, we get 2 times the quantity 2x squared minus 7x plus 6. Now, let's distribute the negative 2 to get a equals 4x squared plus 12 minus 4x squared plus 14x minus 12. We can combine like terms. 4x squared minus 4x squared equals 0, and 12 minus 12 equals 0. So a simplifies to just 14x. Now, let's simplify expression b. We'll multiply the binomials inside the parentheses using the distributive property. We get 14 times the quantity 2x times 7x plus 2x times 1/2 minus 1/7 times 7x minus 1/7 times 1/2. This simplifies to 14 times the quantity 14x squared plus x minus 1/14. Let's simplify this further. Inside the brackets, x minus x equals 0, so we're left with 14x squared minus 1/14. Multiplying through by 14, we get 196x squared minus 1. So b equals 196x squared minus 1. Now, let's calculate b minus a squared. First, a squared equals 14x squared. So b minus a squared equals 196x squared minus 1 minus 196x squared, which simplifies to negative 1. Therefore, b minus a squared equals negative 1. Finally, we need to raise this result to the power of 2000. We have negative 1 raised to the 2000th power. Since 2000 is an even number and a negative number raised to an even power is always positive, the final result is simply 1. Let's understand why this works with a visual representation. When we take powers of negative 1, we get a pattern. Negative 1 to the first power is negative 1, negative 1 squared is positive 1, negative 1 cubed is negative 1 again, and negative 1 to the fourth power is positive 1 again. Let's begin with the following problem. We need to simplify the expression 3a squared plus 3b squared plus 6ab. where a equals 2x cubed minus 1 and b equals 2x cubed minus 4. Our first step is to apply the substitution rule. We'll replace a and b with their actual expressions. Step 1. We plug in the values of a and b into our original expression. Next, we'll apply the definition of squaring. Step 2. We'll rewrite each squared term as a product of the same expression with itself. Step 3 involves expanding each product using the FOIL method or the distributive property. FOIL stands for first, outer, inner, last, which reminds us to multiply each term in the first bracket with each term in the second bracket. Now in step 4, we'll compute each term by multiplying the values. For example, 2x cubed times 2x cubed equals 4x to the 6th power. 2x cubed times negative 1 equals negative 2x cubed, and so on. For step 5, we'll simplify inside each set of parentheses by combining like terms. Within each bracket, we'll add the coefficients of terms with the same variable and exponent. Moving on to step 6, we'll apply the distributive property to multiply each term inside the brackets by the coefficient outside. So we'll multiply by 3 in the first two groups and by 6 in the third group. In step 7, we'll group like terms together from all parts of our expression. We'll collect all the x to the 6th power terms, all the x cubed terms, and all the constant terms. Finally, for step 8, we'll compute the final result by adding the coefficients of like terms. 12x to the 6th plus 12x to the 6th plus 24x to the 6th gives us 48x to the 6th. Negative 12x cubed plus negative 48x cubed plus negative 60x cubed gives us negative 120x cubed. And 3 plus 48 plus 24 gives us 75. So our final answer is 48x to the 6th minus 120x cubed plus 75. Welcome to this video where we'll prove an interesting algebraic identity. We're going to prove that the expression x minus a times b minus c plus x minus b times c minus a plus x minus c times a minus b equals 0. Let's start by expanding each term in our expression. We'll use the distributive property of multiplication to expand each of these products. For the first term, we have x times b minus x times c minus a times b plus a times c. For the second term, we get x times c minus x times a minus b times c plus b times a. And for the third term, we get x times a minus x times b minus c times a plus c times b. Now, let's combine all these expanded terms. We'll add all the expansions together. So we get x times b minus x times c minus a times b plus a times c, plus x times c minus x times a minus b times c plus b times, plus x times a minus x times b minus c times a plus c times b. Now, let's group like terms together. We'll rearrange this expression to group terms with similar variables. This gives us x times b minus x times c minus a times b plus a times c, plus x times c minus x times a minus b times c plus a times b, plus x times a minus x times b minus c times a plus c times b. Let's further simplify by collecting like terms. When we collect the terms with x times b, we get x times b minus x times b, which equals 0. For x times c terms, we have negative x times c plus x times c, which also equals 0. For x times a terms, we have negative x times a plus x times, which is 0 too. For a times b terms, we have negative a times b plus a times b, which is 0. For a times c terms, we have a times c minus a times c, which is 0. And for b times c terms, we have negative b times c plus b times c, which is 0. When we add up all these terms, we can see that every term cancels out with another term, leaving us with 0. Therefore, we've successfully proven that the expression x minus a times b minus c. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.